Okay, so today we're going to look at a forces problem as resultant forces problem. It was a problem that caused lots of people to make mistakes when it was in the exam. Um, so if we have a look, start off, we've got a fisherman pulling a boat. There's our fisherman pulling a boat. The forces acting on the boat are 300 newtons from the fisherman, and the sea is resisting it. So we've got some friction. 250 newtons. So the units are nice, and the diagram pretty much shows us what's going on. We've got 300 newtons in that way, 250 in that way. So we've got a resultant force. We've got two opposite forces. So 300 take away 250. The resultant force is 50 newtons in that direction. It's an unbalanced force. So if we know the forces are unbalanced, we know the motion is going to be changing. There's going to be some acceleration or some turning. And it's asking us to describe the motion of the boat for 2 marks. So we need to say that. We need to say that the unbalanced force causes the boat to be accelerating in this direction. And there's 2 marks. So I think lots of people got the fact that the boat was going in that direction, but they needed to say that it was changing speed. And the second mark is talking about the acceleration in this direction. So this is where the problems really start to occur, this next bit. When the boat reaches the land, the resistive force increases to 300 newtons. The fisherman is still pulling it at 300 newtons. Describe the motion of the boat. And lots of people saw these 2 forces and said they cancel out. Therefore, the boat must be stationary. That is not the correct answer. Newton's first law tells us that an object will keep doing what it's doing unless there are unbalanced forces. If the forces are balanced, it will keep doing what it's doing. When it hits the beach, it's moving. The forces are balanced, it's going to keep moving. And the forces are balanced, so it's not going to accelerate. The forces are balanced, so it is going to keep moving at a steady, constant velocity to the right. Yeah, and that's what the description has to say here. Newton's first law is going to show, well, explains that an object keeps doing what it's doing if the forces are balanced, and the forces are balanced. Okay, the last one is to do with adding a couple of vectors. And we've got 300 newtons here and 300 newtons here. And we've got these 2 arrows to represent that. And if we're going to add one of these vectors to the other, then what we need to do is draw a little line. So that line there represents that force. What you would need to do, and it's a bit easier on the whiteboard, but what you would need to draw is to draw a line of a similar size and direction, but you're head to tailing it. You're putting this arrow on here. And I would always recommend playing it safe to do a similar one here. You take that, and again, you can move it across to there. And that tells us that our resultant force, if I put that like that, our resultant force would be that force there, a combination of those 2 things there. And what you might do is measure this and see what the size of that line is. And if that line was 3 centimeters, you would know the scale is 100 newtons equals 1 centimeter. Yeah. If it was 1.5 centimeters on there, you would know that 0.5 centimeters equals 100 newtons. Whatever the scale was, let's assume that it is that's 3 centimeters. Then you would measure this. I don't know, maybe this line here is something like 4.6 centimeters. You refer back to your scale. Okay, that's going to be 460 newtons in that direction. And we look at the line. Is the length of this line here, is that reasonable? If that length is 300, is that reasonable? It's 460. Yes, that looks reasonable. Okay.